Hello everyone, I'm Sonalika from Cloud and Infrastructure team. Welcome back to our Sysinternal tool series. So in our previous episodes, we explored a few important Sysinternal tools and understood how they can help us manage, monitor, and troubleshoot a Windows system. We started with BG Info, where we learned how to display important system information directly on the screen, such as computer name, IP address, operating system information, and other system details. After that, we explored Zoom It, which is especially useful when we are presenting or demonstrating something that on the screen because it allows us to zoom, annotate, and highlight important areas. So far we have looked at the tools that help us understand the system, organize our workspace, and present information more effectively. In today's episode, we are going a one level deeper. Today we are going to look at Process Explorer. Now let's move to our next sysinternals tool, that is Process Explorer. You may already be familiar with Task Manager, which gives us a basic overview of process running on a Windows system. So why do we need Process Explorer? That's where the phrase on the slide comes in, Task Manager with a lid off, which means by this that Task Manager just gives us a basic view of the process, while the Process Explorer allows us to look much deeper into those processes. For example, Process Explorer shows the process in a parent-child tree, so we can understand which process is actually started, another process. We can also select a process and use the lower pane to see more information such as DLL loaded by that process and files or other resources it currently has open. So instead of only asking what a process are running, we start asking who started this process, what the process is using, and what resources does it has open. We will see all this in practical when we go through a live demo. So before moving to the tool, let's understand why Process Explorer is different from normal Task Manager. So here we can see a simple comparison between Task Manager and Process Explorer. So Task Manager is very useful when we need a quick overview of running application and resource usage. But when we need a deeper troubleshooting, Process Explorer gives us much more information. For example, Process Explorer gives us full parent process chain so we can understand how the process was launched. It also provides a DLL and a handle view in the lower pane. Another useful feature is Control F, which can help us to find which process is holding a particular file or DLL. It also provides additional security related information, including verified signer and viruses tool information. And the Process Explorer gives us more process control and investigation options, such as suspending a process, working with process tree, and investigating thread. So the main difference is simple. Task Manager is great for basic monitoring, while Process Explorer gives us deeper visibility for investigation and troubleshooting. We will see this difference in a live demo. Now that we understood why we would use Process Explorer, let's look at how we can actually read the information displayed in the tool. So this slide is about reading the Process Explorer windows. At first, the interface can look a little complicated because we have many processes, column, and different color. But the color can actually give us useful information. For example, pink represents processes hosting Windows service. Purple indicate a packed image, which can be something we want to investigate further, especially for a security perspective. Green indicates a process that has just started, and red indicates the process that has just exited. And blue represents process running under the same user account as a Process Explorer. So the slide also shows the lower pane where we can switch between DLLs and handles. So we can look at a process. We are not just looking at the same name. We can look at its PID, CPU, usage, security information, loaded DLLs, and open handles. So now that we know how to read the windows, let's talk about where the Process Explorer becomes really useful in our day-to-day troubleshooting. So basically, this slide shows four practical situations where we would actually open Process Explorer. The first is when a file is in use. For example, if Windows tells us that a file cannot be deleted because another process is using it, we can use Process Explorer to find which process is holding that file. The second is CPU spike. If a system suddenly has high CPU usage, we can sort the process by CPU and investigate which process is responsible. We can then go deeper into its thread and other details. We have the third situation when we find a process that we don't recognize. We can investigate that process, check its signal and virus tools information, and look at its parent process and other details. And the fourth is who started it. The process tree helps us follow the parent chain and understand where a process came from. For example, a process launched by a normal application can tell us a very different story from a process launched by an unexpected application or documents. So these are not just features that looks good on the screen. These are the features we can actually use when troubleshooting a Windows system. And in live demo, I will take you through these features one by one and show you how we can use Process Explorer in a real situation. So now that we have a basic understanding of what Process Explorer is, what it can do, and why it is more powerful than a simple process list, let's move on to the live demo. I have the Sysinternals Suite folder open here, where we can see different Sysinternal tools. For today's demonstration, we are going to explore Process Explorer. Here we can see the Process Explorer is executable. Since I'm working on 64-bit Windows system, I will use this 64-bit version Process Explorer. I'm just simply going to click right click and select Run as an administrator. So running it with administrator privileges is useful because it allows Process Explorer to access and display more information about process, especially when we are investigating system level process. The first time we launch the tool, we may see Sysinternals software license term. This is simple. The license agreement for Sysinternal tool. I'll simply click agree and continue. After that, now the Process Explorer is open. This is the main Process Explorer interface that we are discussing, that we had discussed in the slides. From here, we can start exploring the running process and understand what is happening inside the system. So let's start with the basic interface and understand what are we looking at. So this is the main Process Explorer window. At first, we can see a lot of information on the screen. So let's understand it step by step. The main area of the window shows up the process that are currently running on this Windows system. Each row represents a process and the column next to it gives us the additional information about that process. First, let's understand what a process is. So a process is basically a program or a system component that is currently running. For example, when we open an application, Windows creates a process for that application. Windows also run many processes in the background to perform different operating system tasks. So everything we are seeing here is a process that is currently running on system. A very simple way to remember is program running equals process. The first column in the process, uh, the first column is the process column. This shows us the name of each running process. For example, here we can see process such as systemservice.exe, svchost.exe, smss.exe, and others. The point to the then point we have the tree column. You may also notice that some processes are slightly indented under the other process. This is because Process Explorer shows up the relation between process. We'll come back to this in detail when we talk about process tree. And on the left, we can see the small minus and plus icon. These are used to expand and collapse the process tree. A minus sign means that the process is currently expanded. So we can see the process underneath it. The next column, we have the CPU. This tells us how much CPU resources a process is currently using. For example, we can see different CPU values for a process here. If a particular process is using a lot of CPU, we can sort this in column and investigate that process. We'll do that later when we cover CPU troubleshooting part. One important point here is system idle process. The high value here represents CPU that is currently idle. So it does not mean that a system idle process is actually consuming this much process, CPU. The next column, we have private bytes. This gives us information about the memory that is privately allocated to process. In simple terms, it helps us understand how much private memory a process has allocated. Next, we have working set. This shows the amount of physical work that is currently being used by the process. So private bytes and working set are both related to memory, but they represent different things. Next, we have PID, which stands for process ID. Every running process has a unique process ID. For example, we can see that system has process ID as 4 and service.exe has process ID as 712. The PID is useful because it allows us to uniquely identify a particular process. Next, we have a description of what the process is. This gives us the description of what the process is. The last column here is company name. This tells us the company associated with the process. For example, many of the Windows processes shown here are associated with the Microsoft Corporation. Right now, we have selected the registry process. When I click a different process, that process is being selected. The selected process is important because many of the actions and additional information we look at the Process Explorer will apply to the process we selected. At the bottom, we can see here the status bar that gives the overall view of the system. Here we can see the overall CPU usage, commit charges, processes, and physical usage. At the top of the Process Explorer, we can see the graph. This gives us a quick visual view of different system activity. So currently, my lower pane is showing handles. A handle is basically a reference that a process uses to access an object managed by Windows. These objects can include things such as file, registry keys, event, and other system resources. So when I select a process in the upper pane, the lower pane can show the handles that belong to that process. So now we can go to view, lower pane, and we can select what we want. like I selected DLL. So Process Explorer gives us another lower pane view called DLLs. Notice that the content of the lower pane have changed. Instead of handles. Now I'm seeing DLL. I can even hide it. So now I can see the lower pane disappears. I'm back to normal Process Explorer view. So when would I actually use this to view? If I simply looking at a running process, I can work with upper pane alone. If I want to investigate what resources a process is using or accessing, I can enable the lower pane. Handles are useful when I am investigating things like files or other objects associated with the process. DLLs are useful when I want to see which libraries are loaded into a particular process. So, the lower pane gives me deeper information without opening the process properties windows. So, to summarize, Process Explorer gives us a deeper visibility into what each process is doing. We can use handles to understand a resources a process is accessing, DLLs to see the libraries loaded by a process, and find handles or DLLs to quickly locate a process associated with a specific file or DLL. These capabilities make Process Explorer very useful for troubleshooting and investigating. So that's it for this video. Thank you for joining us and watching the Spotlight series. If you found this video informative, don't forget to do like, share, and subscribe for more such technical content. Stay tuned for a next video where we will explore the RAG concept over Chroma MCP server in depth.